Hey guys, Mr. R here, and today we are going to talk about part and whole relationships in math problems. And when you're looking at a math problem, when we read a math problem, as you're reading, I want you to try and identify, okay, the information that I'm being given, am I being shared the parts or are they sharing the whole thing with me? Because that's going to matter. That's going to depend on which operation you will do when you solve the math problem. And again, that's our purpose. Our purpose is to know which operation to perform when we're solving a math problem instead of just grabbing keywords and grabbing numbers and taking off and just kind of guessing. If we can identify the parts and the whole and the relationship between those, we'll know which operation to do. In this video, you will see three types of problems with the part and whole relationship. You will see problems with two parts. You will see a problem with a part and the whole thing given. And you will see a problem with three parts or more. Going to jump right in. With this math problem, you need to read it 2 times. And I know that Caro's done a video about this. When you read a word problem, you need to read it 2 times. That's going to help you identify the information, what are the parts, what are the whole thing, and what you need to do. Giselle weighed 2 different samples of chemicals in her science class. The first sample weighed 39.05 grams. The second weighed 56.7 grams. She then mixed the 2 chemicals together. What was the weight of the combined samples? And I know you're saying, Rickerhoff, I don't need to read this to know what to do. I'm good. The goal of this lesson and this video is for you to see the part and whole relationship. No need to take off and try to solve it yet. Let's see what they are giving us. I'm going to switch colors. Giselle weighed 2 different samples of chemicals in her science class. Right here, so I know I have 2 different things that my radar should be looking out for. The first sample weighed 39.05 grams. And I have that information here, and the first sample. And we know that she had 2 different samples. This is the first one. That's just part of it. That's not everything. That is just a part. The second weighed 56.7 grams. There is the second sample. That is another part. She then mixed the 2 chemicals together. What was the weight of the combined samples? And you're like, Rickerhoff, I know what to do. Fine, but let's look at the pattern that I'm wanting you to see here. I have a part here and a part here. When you're solving a math problem, you're going to do what you've done your whole life with parts. You're going to put those parts together, whether those parts were a puzzle piece or Legos, but you know what to do with parts. With parts, you're going to put them together. You're going to combine them. You're going to make something bigger when you put stuff together. So that limits us to those 2 operations for the most part. You're pretty much either going to add or multiply. And then you use your context clues in the information here to figure out, oh, I need to add because I am combining. I am putting together. This problem is an example of just having 2 parts. Going to look at another problem here. Again, I'm going to read it 2 times. And the first time that I read it, I'll get the information there in blue. The second time, I'll use red, just like in the last problem. Maria bought a bicycle lock with a $10 bill. And I know your brain's going to grab the numbers the first time you read it. The bicycle lock cost $6.27. How much change did Maria get back? I've read the problem once. I've got a feel. I know the numbers that are here. Now, when I read the second time, I want to be looking the information that's being given to me. Is that the whole thing or is that a part? Maria bought a bicycle lock with a $10 bill. That is the whole thing. That's all the money that she has. Maria has $10. If she has a $10 bill, and you've been into the store before, when you go in with money, you don't come out of the store with more money. If you are spending, that number is going to shrink. You are going to have less money. When it's the whole thing, you can't get bigger than the whole thing. That's why I had a pizza at the beginning. If you have a whole pizza, after you eat, you're not going to have 1.5 pizzas or 2 pizzas. You're going to have less. That's why I want you to identify these patterns. Oh, if it tells me the whole thing, it's got to get smaller. The bicycle lock costs $6.27. Well, that is a part. That's part of this problem. It's not the whole thing. This is just the $6.27 is just a part. How much change did Maria get back? Well, I know the whole thing is $10 and it can't get bigger, which means I'm not going to add to solve this problem and I'm not going to multiply. I am either going to subtract or divide. That's when I use the clues in the problem. Well, it cost $6.27. So that's money that she spent. And how much change did she get back? I need to subtract. She had $10. She spent $6.27. It's pretty much asking you how much is left. This pattern is the whole and part. I'm going to look at one more. With a word problem, you have got to read it 2 times. Kelly bought 2 notebooks for $3.15 each. And again, I know the numbers are going to jump out at you the first time you read it. And a backpack for $12.40. How much money did she spend? And again, we've got another situation here about spending money. And you might just take off and say, ooh, subtract, just like the last problem. That's why I'm not telling you to pull just a key word here and take off. Let's identify the part and whole relationships here. Kelly bought 2 notebooks for $3.15 each. So 2 notebooks for $3.15 each. I've got 2 parts just right here. Each notebook was $3.15, so that's $3.15 and $3.15. And a backpack for $12.40. Just because it's the biggest number does not mean it is the whole thing. That $12.40 is another part. You might be wondering, how do you know that, Rickahoff? I know that because I've been to the store before, and some items cost more than others, and you've been to the store before. When you go, you lay stuff down on the conveyor belt, or you're doing your self-checkout, and every item, boop, boop, boop. Every time you hear that sound, it's putting all those items on the receipt, and it's going to add them up. It's going to combine all of them. So let's look. 2 notebooks for $3.15 each. I've got 2 parts here, and a backpack for $12.40. Another part. How much money did she spend? This problem does not tell me the whole thing. It's my job to figure out what the whole thing is. What am I going to do with these 3 parts? The same thing that I've done my entire life. When I have a bunch of parts, I'm going to put them together. It's going to get bigger, which means I am going to add or multiply. And based on what it's given me here, she's spending money, I am going to add all of these parts. At the store, that's what they do. They ring up each item gets scanned, They add it up and tell you the total. The whole thing. We have to figure out the total. This is when you have 3 or more parts. If the problem lists a bunch of parts for you, you need to put those parts together. There is a Google form that I want you to try after you've watched this video. I do not want you to solve those problems. On the Google form, read the math problem and then figure out which pattern. And I'll show you again here. Your choices on there, on the Google form, are going to be 2 parts, the part and whole, or 3 parts or more. Those are going to be your choices. I'm not going to ask you to solve it. I'm going to ask you to be on guard for those patterns so that you know which operation to perform.